Hello, I'm FX. So when we offered a couple of options in terms of talks that we could give at SIGINT, apparently the reaction was, quote, "We want this with the LSD slide," unquote. So this is what they got. And this is Greg. He actually knows what he's talking about. So this is why he's speaking with me. To cover my ass. And we're going to speak about cloud computing. So, because it's early in the morning, we can't do the drinking game with every time you say cyber, you need to drink. So we say cloud a lot today. Okay? Now, let's start. Let me give you a short intro, like tour de force introduction on cloud computing in the sense that we're discussing here. If you consider cloud computing, it's mostly based on the concept of virtualization. Now, generally, virtualization means that you essentially abstract away a existing resource, and you put a couple of intermediate layers in, so you have more fine granular control over how this resource is used. And also you have kind of like a standardized interface, right? So that's pretty much what virtualization in the general term means. Depending on who you talk to and how much cocaine they had for breakfast, this might actually mean a different thing for different vendors, right? So there's the typical virtualization vendors. They will mean with virtualization, they say an abstraction of CPU, RAM, storage. If you talk to the QEMU guys, it's probably more the emulation of hardware that they don't actually have because they're not old enough, so they don't have the collection of old MIPS machines that I do. Or if you talk to other people, like let's say networking people, it might actually be the ability to tell two routing tables apart from each other. So as an engineer in Cisco once told me, like, our virtualization is actually 1 bit. Because it says it's the primary or the secondary routing table. So that's all virtualization that Cisco IOS does, for example. But the term virtual shows up in the documentation all over the place. Now, if you think virtualization is a really new thing and cloud computing is a really new thing, then you're too young, which is good for you, but bad for your understanding. Because actually computers used to be virtualized and used to have hypervisors from the beginning on because the shit was just fucking expensive, like the hardware, the metal was. And the only time where virtualization, is that micro working? Yeah. The only time that virtualization actually became like rare was when people started to buy PCs. Hence the term personal computer, because everyone had one, so you didn't need to virtualize, right? As you see, hypervisors and virtualization are likely older than you are. So with virtualization in the modern way, in the modern term, come a number of pretty wrong assumptions. So because you're isolating something in a virtual machine, people tend to think that makes it more secure. Well, general rule of thumb, if you think something you do that is not really hard work and really uncomfortable to do makes something else magically more secure, you're probably wrong. And that's the case here as well. So just because it's fucking isolated doesn't mean this is a security feature. It's actually functionally isolated. So a VMM, a virtual machine monitor, which is the core of a hypervisor, is actually designed to minimize trapping. So it is designed to run as little code as possible, which also means it's not a security monitor. There is hypervisors coming out now that actually do that, but this is not the design goal for most hypervisors. And if you do virtualization properly, then you still don't get new security boundaries, right? Because the perfect virtualization means that it behaves as if you had a physical system. Now, you don't get additional security boundaries, but you might actually lose some For example, if you have two computers sitting next to each other, it is fairly unlikely that magically a piece of data just walks over from one hard drive to the other. If you have all your virtual machines connect back to the same storage system or ZAN, this might actually happen depending on how fat your fingers are. So, having clarified this, let's go into virtual networking. Because, well, now we have all virtual machines. They're sitting somewhere on lots of metal. Now we actually have to virtualize networking as well, right? That's good and fine. The problem is that we don't actually just virtualize networking, but we also virtualize stuff that we tend to put onto networks, and we shouldn't have done that to begin with. Namely, storage protocols, fiber channel, iSCSI. I still have dreams about, laughing dreams about talking to the people that came up with SCSI and their face when you say, well, now we run it over TCP/IP. If they're not dead yet, they probably kill themselves. So this is all that stuff, and then of course we need to connect virtual network interfaces, right? That we put into the virtual machines, and we need to connect those. So we have a virtual switch, and that virtual switch will eventually, in some iteration, have an uplink to a physical actual network, shit that you can kick, right? The definition of hardware. So there's different implementations, there's different vendors that sell you, virtualized networking. Now, what we talk about here is Cisco's virtualized networking environment, which so far is the most widely used, not very surprisingly or very surprisingly. So the way Cisco does that is essentially the virtual switching is the virtual equivalent of a large catalyst switch. If you ever looked at a catalyst switch, so they have a big enclosure and one or two power supplies, and then there's a couple of line cards. One or two of them actually contains the main CPU, RAM, flash memory that is never enough for the latest image, and the other stuff that you need. And then the rest of it is essentially line cards with ports. Lots of holes where you can connect Ethernet to and then get porn. So the way they do that in the virtual world is this is an ESX machine, and so VMware ESX host, and the equivalent of the Ethernet port cards is now a bunch of kernel modules in the ESX called the VEM, the Virtual Ethernet Module, right? So it's the virtual line card. And then there is the actual supervisor card, like the equivalent to that has the CPU on it, is the virtual supervisor module, VSM, and that's actually a virtual machine or two. So, because for high availability and blah, 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 it needs to be a virtual machine. Also, virtual is cool. Which, and that you should keep in mind for later on, also means that what used to be the backplane, like this piece that connects your line cards in the enclosure, is now on the network. And for that, it needs to be protected, but we're coming to that. Now, in this thing, you can essentially take virtual ports or port groups and assign them to virtual machines or make them part of the management network. So the whole security in cloud computing in the VMware world and also in other vendors' worlds, but VMware being what we discuss here, the whole security comes from we separate the user network from the management network. Question, why? This is why. This is how a management network tends to look like. So as you see, to use a military term, this is a target-rich environment. So wherever you shoot, you can't possibly miss. You just shoot at something and then declare the combatant later. This works really well for some states. So this is a single ESX host. This is a single vCenter. You can obviously have more than one, which obviously increases the number of lines here. Most of this is HTTPS or SSL. All of this uses self-signed certificates. There hasn't been a single VMware vSphere cloud identified yet that actually has a PKI. Because it's just a fucking nightmare to roll out. So nobody actually does that. They use certificate pinning in most cases. But there's also like lots of fun protocols that you really, really, really don't want anyone else to mess with, like fault tolerance and high availability, where you essentially can own, or vMotion, where you can actually own a virtual machine while it's transferred from one host to the other. But essentially, this is where you want to get to. But usually, you're not supposed to be there. Now, let's look at this Cisco Nexus product family. Right now, we have that theory that the product is called 1000V because that's the victim count. So, NXOS. NXOS is Cisco's new operating system, because they're so good in developing operating systems, is their operating system for the Nexus product line. It actually comes from a storage area network vendor that Cisco acquired and was developed for a product line that is called MDS. And it's essentially Linux with a brand new, fresh 2610 kernel. And so what we discuss here is pretty much like the more or less latest version. When you connect to it, when you SSH into it, which tends to be challenging if you have too many identity files, then you end up in a shell that's called VSH, and that essentially behaves like Cisco IOS from the CLI, so the networking people don't need to learn new shit. If you happen to look at the process list, for which you actually need to root the device, but we're coming to that, you will figure out that your VSH is the only process that actually runs under a user not root. So your shell is the only process that is not root, but you're supposed to be the admin of the device. Now, as I said, NXOS runs on actual hardware. But it also runs on virtual things, right? So it runs the 1000V, which is the virtual switch. Then there's a virtual appliance called the 1010, which is a virtual router. Basically, I found one single binary on this whole thing that contained the string Cisco. Everything else is open source, which probably is good. However, that open source is kind of like not updated, so their routing daemon is Quagga, but it is far from the latest version. So they actually ship with a bunch of known vulnerabilities. And of course, because this is also stable and good, there is also a virtual security gateway as a virtual firewall. This makes as much sense as it sounds, right? So. But it is a well-selling product. Now, you want to look at NXOS, and of course, you go like, okay, my shell is the only thing that doesn't run as root. How do I change that? So, me being the stupid and pragmatic person, I'm like, oh, it's a virtual machine, so I can actually boot from a virtual CD-ROM, which runs a virtual Linux, and then I can actually just mount the hard drive and see what's on there. Turns out, they actually keep their Linux side of the configuration in two partitions. And then there's a bunch of etc files like password and shadow and other things that are used for authentication. And then they make it into a tarball. Then they make the tarball into a tar-gz ball for whatever reason. And then they memorize a checksum, which turns out to be just the MD5 sum of that tar-gz ball. So essentially all you do is you mount that thing and unzip and modify shadow and password, and then you have an additional account that actually has a bash. Now, funnily enough, when they boot, apparently there's some piece of magic that tries to check whether there's a root account that doesn't belong on the box, so root accounts disappear. But of course, you can actually modify other files. So what I opted for is creating a new service entry and bind a root shell on port 25, because I was pretty sure that the router or switch will not need to send email. Or receive email for that matter. So, you know, the nice thing about that is the VSMs, as I said, there are often two of them because in physical switches you have two supervisors. In case one dies, the other one takes over. So they also have that concept with the VSMs. The nice thing is if you jailbreak one and you boot the other, it auto jailbreaks itself. So at least that config syncing works as expected. So this is all you need for a jailbreak. That's the entire jailbreak that you can run when booting from a CD. But then, you know, I have colleagues that just can't deal with something that needs to be booted from the CD because occasionally you don't have that level of control over a router or switch. And so Greg came up with an alternative solution. Good.
Yes. Sure. So yeah, or you just fail to realize that you can actually boot a CD in a virtual machine. So anyway, let's start at some actually unrelated topic. So the Nexus 1000V, it's kind of unrelated. As Cisco wants to make money, they thought it might be a clever idea to put a licensing scheme in place. So in order to actually use that whole piece of Cisco crap, you need to obtain a license file. And Cisco actually didn't implement that themselves. They use a product called FlexNet Publisher License Manager. And in order to ensure compatibility with our existing network infrastructure, we had to disassemble that. More details are provided later. It's plausible. So what you can just do is you can just grab the binary files, boot up yet another virtual machine to start IDA, put the binary files into IDA, and start disassembling the shell, which implements the install license command. So there you go. So you disassemble the shell daemon file, and you find a number of references to a function called lickmgr something, which sounds like license manager. So I was like, okay, cool. Let's grab the license manager binary, disassemble, and there you find a function called lickmgr validate license. Okay, cool. License manager, debug symbols. Okay. It does make sense.
Level 1 creepy.
Probably to someone. At least it's easy to debug. So you go and disassemble a function, obviously, and what you find is the following excerpt of code. So you see they store the license file name in EAX, do some magic, set up some commands, and call snprintf actually. And I was like, oh, they use snprintf. Wow, okay. That's pretty cool. Then I read the next line, I was like, aha, so they kick the output of snprintf into system. Yes. Aha. Well, that's best practice, I guess. At least there is no buffer overflow, which is good, and no format string either, which is pretty advanced. Yes. So as you just saw, we just found a command injection, yes, in a license checking module. So I was like, what the fuck? It can't be that easy. Okay, go to the shell, create a file called $braces_halt.lick, install license, and no prompt comes back. And then you hear someone shout from the other room, hey, did you turn off the router? Like, oh. Okay. So yes, that's so much for the licensing scheme and the jailbreak. However, in order to exploit that condition, you need to bring some tricks in place because Cisco does elite and advanced input filtering. Namely, their file names are not allowed to contain a number of characters, which are listed here. Unfortunately, those characters are handy for exploiting command injection bugs. So I was like, okay, like do the typical tricks, yeah, right? Use bash voodoo, use bash lists in order to expand commands and stuff. Didn't work out. Don't have curly braces, don't have spaces. Okay, so, and this is actually a trick. I don't know how well known that is. In Bash, there is this variable called IFS, which means input field separator. And by default, that contains the sequence space, tab, new line. And you can just use that variable in order to put spaces into your commands that you inject without actually using the space key. Okay, so that's my version of the jailbreak. I don't know how well you can read that. Anyway, let me quickly explain what it does. So it first creates a temporary directory and stuff, and inside the temporary directory, we create a file that is going to be executed later called runme. And then we create a directory structure inside our temporary directory, and that directory structure starts with a directory called $foo, and we create more directories and more and more and more. And the interesting part is when we install the license file, then it becomes clear why we actually create so many temporary directories, because when we install the license file, we use the slashes in the directory structure that we just created, and by inserting a space character, oh, there is no cursor, I see. Yeah. Oh, well. Yeah, but then I have to move, I guess. Okay. Okay, fair enough. So you see the space character that we inject here. That's kind of funny because due to the space character, the first slash, which is actually part of a directory hierarchy starting here, the first slash is confused with like the file system root. So what it actually does is try to install the license file. The file already exists, yes. The code is executed as root, obviously, because license manager needs to run as root. And there you go. You create an account in your shadow file, and you can just telnet into the box and log in and be root. That's, yes?
So what we should probably mention at this point is, so after we gave this talk the first time in Poland at Confidence, I'm like, so, does that potentially also work with other MDS products? So we took physical machines from Cisco that run Nexus, as well as EMC MDS devices, which is the company that was originally purchased by Cisco and then went to EMC. Yes, that also works to root all storage area network boxes.
Yeah, that makes it a bit more fun, I guess. Okay, I think it's your part now, right?
Oh, okay, good. So, well, you obviously don't jailbreak production equipment for fun, right? So there is an actual legitimate reason to do that, because you need to fix a couple of things in terms of security. Because the shell provided to you is not giving you the powers to fix them. You need a root account. One of the things that NXOS comes with is a command that they call ETH analyzer, which actually calls T-Shark, so Wireshark text mode. The problem is that while you can actually write PCAP files, they're owned by root, and root only. So with your admin shell, the only user process on the machine, you can't actually get the PCAP files. So you actually have to have the jailbroken root account in order to get the PCAP files in order to debug your fucking network. Also, other things don't work, so SCP doesn't work. You need to fix the SSH configuration, because if you have 3 identity files for RSA, DSA, and ECDSA, as we have with modern SSH client installations, the Nexus box will actually tell you too many authentication failures, because it is configured to only accept 3 tries, and once you tried 3 public key methods, then it will close connection and not ask you for the password. So there's legitimate uses to root the box, right? In order to secure it. Actually, there was a reason that Greg looked at the licensing, because there is issues that go with the licensing system. So this is a vulnerability, or this is actually a bug that was apparently reported to Cisco by a customer. So apparently they still have plenty. And so when they shipped an upgrade to the VEM, the Virtual Ethernet Module, when you rolled this upgrade out, it would actually kind of like no longer understand what the licensing is. So you would say, show me your licensing, and it will say, yeah, you're fully licensed, blah, 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 on both sides, like on the VSM as well as on the VEM. But if you use that in conjunction with a virtual security gateway, the virtual firewall, it will actually think that your licensing is not valid, and therefore actually forward packets from any port to any port without asking the firewall for permission. This was discovered half a year after they rolled out this version. So like half a year long, a large amount of vSphere environment clouds were actually having no firewall whatsoever, internally as well as externally. So in order to work around problems like that, Greg looked at how this licensing works, because this kind of issue might actually come back in later versions. Cisco is good at that.
See, sound legit? Okay. Good. So back to the licensing. So we already know this license manager, and the license manager called this binary using system, right, to actually validate the license. It also executes arbitrary command for us. So if you want to circumvent the licensing scheme, you could actually just exploit the bug there, execute an arbitrary command, get root account, remove the license manager, blah, 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 patch the system. Quite a bunch of effort.
Not a good workaround.
Yeah, it's not a good workaround. So I was like, okay, what does a licensing file actually look like? Okay, it's an ASCII file. It's pretty straightforward. And you see there is something meant to be a signature down there. I removed some fields to protect the innocent, which is us. So and the first thing you observe is, oh, it has a signature. Oh, okay, they probably use fancy crypto then. Wait, so that signature was 12 hex characters, which is 6 bytes, which is roughly about, I really took some time to calculate the value. It's roughly about 48 bits. 48 bits, wait, that's not too much for an offline attack, I guess. Especially as we have the code that actually validates the license at hand, so we can just copy over the binary and use it. Okay. And I was like, okay, but brute force is pretty lame, and also I'm pretty lazy. There must be an easier way to do it. So, okay, back to the license check binary. You can just copy over the binary and use a debugger in order to trace what it does. Did I mention it has symbols? Okay, so you poke around a little bit, and after poking around a while, you find one function that doesn't have a symbol, which computes the expected signature value of a license file. Okay, so much for fancy crypto. There is no fancy crypto inside there. Good to know. And this expected value is stored in memory, because they need to compare the expected signature to the real signature, which totally makes sense for them. So then I was like, okay, now we could reverse this subfunction and figure out how the expected signature value is actually computed. or you can just use a debugger to grab the expected signature value out of memory. Okay, I said I'm lazy, which I really am. So I was like, okay, I'll just grab the binary, grab all the libraries, copy it over to my machine, and see what I can do. And yes, it's that simple. Just use GDB, set a breakpoint, extract the value out of memory, there you go. And also, if someone paid attention, yes, there is this host ID field in the license file. Please just refer to ISAN etc serial no. Just saying. So if you need to adjust some values there, you know where to touch it. Okay, and this is the licensing workaround scheme that we had to implement in order to ensure compatibility, legal reason, la 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 la. So yes, this is a shell script. Starts GDB, sets a breakpoint, extracts the value out of memory, and generates a license for you. So much for the licensing scheme. So now if Cisco ships an update again, which disables the licensing scheme, you know where to look at the code and adjust the stuff that you need to adjust in order to make it work again. Okay.
Yeah, we officially disclaim any responsibility for loss of financial transactions to Cisco resulting from those workarounds. So now that we actually have root on all the stuff, we can look further and see, if we can actually use that for, what the security impact of using Cisco products in the cloud is, and if it is somehow comparable to the security impact of using Cisco equipment in your network. So we look at the cloud and we go you have a nice cloud there. It would be a pity if something would happen to it, right? So the first stop shopping with any Cisco product is their own protocols, primarily CDP. CDP is obviously a Cisco invention, the Cisco Discovery Protocol, it's probably also named the Cisco Discovery Protocol because they rediscover it every time they ship a new product. And what they usually do is they add a new field. It's a type length value type of protocol, and for every new product they add a new type. And for every new type they add, they write new code, which for every new code they write has a parsing vulnerability. So the ESXi ship from VMware contains a single binary that is actually contributed by Cisco. It's called netCDP, and it does have a parsing vulnerability in the CDP parsing code, obviously. So this actually, this actually is not really exploitable, but it gives you an idea. Now, looking at CDP, Cisco recently put out an advisory, which they occasionally do, again on CDP, and they said, well, we discovered a couple of more issues with CDP, and affected is the entire Nexus product line. And the UCS, which is the server manager for the Blade Center. So apparently there's a bunch more of CDP vulnerabilities in there. It is beyond me how you can fuck up something that you invented yourself, 2 decades ago, and every time you screw something on it, you screw it up. Good. But now let's talk a little bit about how the VSM and the VM actually operates in a cloud environment. So, as I said earlier, everything in the vSphere cloud is supposed to be HTTPS or SSL wrapped one way or another. And it usually actually uses certificate pinning. And now the VSM actually also uses the vCenter, so the central management server, in vSphere environments to store parts of his configuration. It stores lots of other parts of its configuration locally, and I have absolutely no idea why it needs to put this little piece of bootstrap configuration onto the vCenter server, but it does. Now, Cisco is actually the only vendor that has not figured out that when you use SSL, you should actually look at the certificate that you get and, you know, make some basic validations. So in the vSphere cloud, they're the only ones that, you know, talk SSL to whoever happens to be the man in the middle. Well, Apple does that for the entire internet, but that's a different story. So how do the VSM and the WEM, you know, I mentioned earlier that now the backplane of your switch is on the network, right? So how do they actually talk with each other? When you look at that, it turns out that they have two modes of communication. One is called the layer 2 mode, one is called the layer 3 mode. The layer 2 mode uses a custom frame format, which turns out to be also used it is very likely to be the same protocol that they use on the actual physical backplane of physical switches. And you can talk to me later on why that possibly is. But it's a Cisco invented protocol. IEEE 802.3 uses custom PIDs, two different PIDs. We're coming to that later. And then when they talk to each other, they use broadcast, of course, because bandwidth is cheap, or they want to sell more switches, or I don't know. So it uses broadcast, so it talks around in your network. If you set this up, your physical network will be pretty much unusable because you have broadcast storms all the time. Alternatively, you can use the layer 3 protocol version, which uses UDP. Also broadcast, or multicast, or directed, but occasionally broadcast. So what you have is you have a control and you have a packet channel. So the control channel, as the name suggests, is the control communication between the supervisor and the Ethernet module. The packet channel is actually where they forward very important protocols, very important internal protocols, like CDP. And IGMP and LACP for the link aggregation shit, but primarily CDP. So this is where you get like packets that are forwarded to all ports. The used protocol is completely undocumented, this being Cisco, and you know, we started looking at it. You know, it starts with, you know, it has a protocol type, then it says which direction it goes. Then it has a 7-bit field that can have two possible values. This is either raw or encrypted. Then there is the encryption that they use is called ISAC. There's a version, that's always 1. There's a key counter, that's always 1. And then there's two fields that left me puzzled, because you can say, well, one field says, look, this packet is encrypted, and the other says it's supposed to be encrypted. Wait, wait a moment. So actually, you can turn off the entire encryption from the sender side. Like, you just say, I'm not encrypted and I'm not HMAC'd, and then, you know, the encryption and the HMAC check is not applied. Why the sender is allowed to decide whether encryption is used or not is beyond me, but, you know, this is how they do it. Now, if you ever ran any infrastructure using Cisco equipment and software, you know that the most important command that you possibly can have is debug. Because, you know, without that, shit is not gonna work. So, of course, you can also debug stuff on the virtual machines. So on a VEM side, there's a tool called VEMlock, where you can turn on debugging. However, be advised, if you turn on debugging, then the special flavor of Cisco code is executed, which takes values directly from the packet and uses them as index into arrays in a kernel module in order to create an output string with very expected results. If you're not familiar with that, that's the so-called purple screen. This is when a ESX server has a kernel crash. So by introducing Cisco kernel modules in your ESX host, you also introduce kernel vulnerabilities. Mind you, this is totally exploitable from a virtual machine. So now that we found this, because unfortunately this turns out to be actually a read exception in memory, and I didn't bother to see if I can turn it into an actual exploit because there's more. But this, you should, like, if you take anything away from that here is, if you want to break out of a virtual machine, don't try to fuck with a hypervisor, send a couple of packets, the Cisco kernel modules will take care of the rest. So they have a couple of interesting protocols. So which they all pack in this undocumented protocol. Now, since we can actually now more or less read and speak this protocol and turn off encryption, so one of the things they do is every 30 seconds, or no, 10 seconds or so, they broadcast from the VM, they registered themselves on VSM with broadcast messages saying, here, this is who I am. Now, how they identify the actual host that they run on is they use a UUID that VMware generates when you install ESXi. It is the hardware UUID. This was a tremendously stupid choice because that's the ID that actually VMware answers to multicast requests for the service location protocol. So something that the host actually tells you as an answer when you ask the host, like, who are you, is a fucking bad choice for a secret. But of course, Cisco took that choice, so you can ask a host for his UUID, and then you construct a packet and send it to the VSM, and then you just became the virtual Ethernet module, which is bad, right? But trust me, it gets worse. So I mentioned that, look, this is how a switch actually looks like, right? A physical switch. Now, I mentioned that there's a layer 3 mode of the communication between the VM and the VSM. You know, as a network vendor, it is surprisingly difficult to actually prioritize your control channel traffic over other traffic. So it is as that simple as flooding the UDP port in order to break this connection, because the keep alive packets, the heartbeats, don't make it through anymore, and then the VSM just like drops the VM. The VM can operate independently, but of course it will miss every possible configuration change that might happen, which might not be a manual process. So, but then, you know, the control and packet channel and the backplane being on the network, Cisco's like, ooh, security impact. What do we do? Now the documentation says the control and packet VLAN communication is encrypted with 128-bit. That is all the documentation says. Now, I look at the binaries, and I'm like, oh, OpenSSL, good. So they didn't write their own crypto code. That's cool. And then, you know, it's AES CBC. But then every time a packet arrives, they reinitialize that with a hard-coded key and a hard-coded initialization vector, and do the crypto. So they turn it into ECB, essentially, and this key is actually hard-coded in all of Nexus products, because they need to talk to each other, right? Well, funnily enough, I actually had a call with Cisco on that, and it took me half an hour to explain to them that, no, I don't have the source code. You know, I don't need the source code. When you call your function, collect key from parts, and then pass the result to AES set key. I mean, sorry. The HMAC turns out to be a SHA-1. So it doesn't have a secret part. You know, it's just a hash. Well, but that means that we can actually now encrypt and decrypt that traffic that we see on a virtual backplane, right? We can also do that from a virtual machine, at least the sending part. Now, depending on the network setup, we can actually do a lot of interesting things. Because we have that key, that magic key that never changes, because then you will have to roll out an entire new code base on your cloud infrastructure. We get to talk to the management network. And talking to the management network is pretty much a game over scenario for any cloud. We can also man in the middle the traffic because, did I mention no PKIs? Which also has funny results because of the certificate pinning. You can actually go ahead and man in the middle traffic and present a totally bogus certificate to servers, and then they will stop talking to the legitimate server forever because they think, oh, that was some evil shit going on, and I blacklist the server. So at some point, like, the vCenter just sits there and plays with itself. Which can be entertaining, but is not the purpose of the exercise. The fun part is this. So the only defense against that right now is to have L2 communication, layer 2 communication instead of layer 3, and have an absolute perfect VLAN setup that never changes. If you ever ran an actual network, you know how likely that is. The L3 version of this, in L2, if you VLAN the Cisco communication away from your customer cloud communication, all good. In L3, it's UDP. You can't actually configure that in a different VLAN because it's supposed to, be dynamic across the whole cloud and stuff, which, funnily enough, is also the base assumption for VXLAN, or as I call it, VXLAN, and other SDN, like software-defined networking bullshit that is coming out lately. This is the actual base configuration that you need to run in order to have the fancy stuff on. So if you have the fancy stuff on, I can own your cloud. So this is the worst case scenario, right? So you virtualize to a DMZ, because that's what people do nowadays, right? So the gray box here is all one ESX. So in your DMZ, you run a web server, and one of your smarter interns install PHP and a bulletin board. So the expected thing happens, right? So someone pwns the PHP bulletin board. He doesn't even need to go for root or an actual privileged account, but he actually only uploads a PHP script that can speak UDP, which happens to be not so hard. And, it talks to your virtual switching stuff there by matter of UDP broadcast packets, and takes over a port group and essentially builds an entire tunnel into your internal network. This is the Chinese RAT, remote administration tool. Now we're, okay, well, bad design decisions happen. They happen more frequently at Cisco than in other places, but maybe it was a single mistake. Now, we take a random NAS, like network attached storage device sold by Cisco, and we look at that, and it is, again, Linux MDS based, and it has web management, and then, just as an idea, you look at that and you find obfuscated Perl code executable in CGI bin. I think we stopped doing that end of the 80s, right? So it turns out that code is actually not even from Cisco, but from PMC Sierra, and it was actually written in the 80s, which explains why it is there. Now, this being Perl, it's like, okay, FTR, that's your shit to do. And so I hand him the code tree, and he is like, well, yeah, the Perl scripts are really funny, but did you look at the initial PHP thing that checks the password? By passing the submitted password to exec in PHP. So you actually get code execution by the password field. So much for other things, right? I mean, there's more gems. There's products. This one, I just love that one. It's, again, it's a LAN management solution, virtual appliance. It runs in the cloud, and it actually binds a root shell to a TCP port for no fucking particular reason. So you just tell that in, and you're good. So, concluding, we reported this in November last year. This is the Cisco bug IDs if you happen to be a Cisco customer and want to kick some ass, because none of this is actually fixed. There is not a single fix shipped. They increased the marketing for the Cisco 1000V Nexus product line. So the most simple fix, which is introducing an additional if statement in a debug output code, is expected somewhere June, July this year. The problem with using a hard-coded key on the most critical protocol that they can run in the cloud is renamed by Cisco to the current solution is the minimal security architecture, and they're expecting to come up with an enhanced security architecture in mid-2014. If you run a cloud environment or a virtualization environment, it might be a good idea to look for another vendor that provides virtual networking to you. Because this is how we think that Cisco's design department actually works. Or at least their specs are as good as that. And with that, we would like to open for questions.